For 7 weeks, a room of engineers outside Tokyo sent the same command into nothing. On the far end, past the orbit of Mars, was a spacecraft the size of a small car, tumbling out of fuel. Its antenna swung 70 degrees off the Earth. No telemetry, no signal, no way to know if the thing was even in one piece. 180 million miles away. Then, on the 23rd of January, 2006, a single tone appeared on a screen. No data in it. Just a carrier wave, a bare hum on the right frequency, telling them something, out there, was still alive. That tone belonged to a probe called Hayabusa, and by every reasonable measure, it shouldn't have been sending anything at all. It had gone dark in early December, spinning, leaking propellant, quietly written off by most of the people who'd been watching. What almost nobody outside that control room understood yet was that the faint signal wasn't the end of the story. It was barely the middle of it. And what came after it is the part almost nobody tells, the part I still have a little trouble believing actually happened. I want to lay the whole 7 years out for you, because the version most people remember is the tidy one. Japan flew to an asteroid, scooped up a sample, and brought it back. That did happen, but that version leaves out that the mission broke, over and over, in nearly every way a spacecraft can break, and that the people running it spent years refusing to give up. This is the story of a faraway probe that got given up for lost at least twice, and answered both times. Almost nothing about Hayabusa went the way it was drawn on paper, because this one battered little spacecraft is the whole reason we now talk about flying to an asteroid and carrying a piece of it home as a thing that can actually be done. The missions that pulled it off cleanly, years later, learned how by watching this one nearly not make it. So stay with me, because the fix that finally dragged Hayabusa back across that gulf of empty space was so improvised, so close to a straight bluff, that the first time I read how it worked, I assumed I'd misunderstood the explanation. I hadn't. None of that recovery makes sense, though, until you know what this machine was and how little it had to work with. Hayabusa launched in the spring of 2003, and it weighed about as much as a small car, a little over 1,000 pounds, with its tanks full. Its target was a rock called Itokawa, an asteroid barely a third of a mile end-to-end, later described as looking like a sea otter floating in space. And Itokawa wasn't a friendly target. It's less a solid rock than a loose rubble pile, a heap of gravel and boulders held together by its own almost non-existent gravity. You can't really orbit something that small because there isn't enough gravity to hold you in place. So the spacecraft would have to hover beside it, matching its slow tumble through space by radar and by eye, and ease down toward a surface where one careless nudge could send it drifting off for good. Touching that, gently, and coming back up, was the kind of thing that looked elegant in a proposal and terrifying in practice. What made any of it possible was the way it moved. Hayabusa didn't burn chemical rocket fuel to cross the solar system. It ran on ion engines, 4 of them, and an ion engine is a strange and patient device. It takes a gas called xenon, gives the atoms an electric charge, and flings them out the back with a magnetic field, and the push you get from that is unbelievably gentle, about the weight of a coin resting on your palm. But it never stops, and it sips propellant instead of gulping it. So over months that featherlight shove builds and builds until the spacecraft is moving faster than any chemical rocket could have driven something so frugal. Honestly, it's one of my favorite pieces of engineering in the whole space age, and Hayabusa was doing all this on an engine the field still half distrusted, one flown in earnest on only a handful of craft before it, which made the whole mission a gamble twice over. The trouble started early, and it never really let up. Soon after launch, one of the 4 ion engines quit, leaving 3. Then, in the autumn of 2003, the sun threw one of the most violent storms of the modern record straight across the solar system, a run of enormous solar flares around Halloween of that year, and the radiation degraded Hayabusa's solar panels and cut the power its engines had to work with. That alone forced the team to redraw the entire flight, and the probe reached Itokawa about 2 years later than planned, in September of 2005. By the time it arrived, 2 of its 3 reaction wheels, the spinning gyroscopes that let it hold a steady attitude, had failed over that summer and autumn. It was now trying to navigate a landing on a moving target with a fraction of the control it had been built to have. The landings themselves were a slow-motion disaster, and this is the part of the story I find almost hard to watch, because the failures just keep stacking. Hayabusa was carrying a tiny hopping robot called Minerva, meant to bounce around on the surface and send pictures back. When they went to release it, the spacecraft was drifting the wrong way at the crucial moment, and Minerva floated off into open space and was never heard from again. On the first touchdown attempt, in November of 2005, the automatic system got confused, and the spacecraft actually settled onto the surface and sat there for about half an hour, unplanned, before lifting off again. That accidentally made it the first craft ever to take off from an asteroid, a milestone nobody had meant to make that day. Then came the real sampling run. The plan was to drop a small reflective marker onto the surface first, one carrying the names of hundreds of thousands of people who'd signed up from all over the world, and use it as an aim point. The marker did go down, but the little device meant to fire a metal pellet into the surface, kicking up debris for a collection horn to catch, appears to have never fired at all. The engineers suspected as much before they even left the asteroid, which meant the sample canister they were carrying home might well be empty. And then, right after that, the worst of it. The spacecraft started leaking fuel from a damaged thruster, and the leak set it spinning, and the spin became a tumble. And on the 8th of December 2005, that tumble swung the antenna off the Earth, and the signal died. As far as most of the outside world was concerned, that was the end of it. By then, the mission had already slipped 3 years behind, burned through most of its luck, and lost a rover, an engine, 2 of its 3 gyroscopes, and probably its only chance at a real sample. In the coverage at the time, Hayabusa was the crippled probe, the troubled mission that had tried too much, and finally broken somewhere out past Mars. Anyone writing it off then was just reading the facts in front of them. And this is the point where the people take over the story, because a silent, tumbling spacecraft doesn't come back on its own. Somebody on the ground has to decide it isn't dead yet. The mission was led by an engineer named Junichiro Kawaguchi. He didn't declare it lost. He reasoned that the leaked fuel would eventually finish venting, and that the faint pressure of sunlight, the same photons that push gently on every object in space, would very slowly nudge the tumbling craft until its antenna swept back across the Earth, maybe for only a few minutes at a time. So the team kept transmitting, and out at that range, even patience was expensive, because a single command took about 16 minutes just to crawl out to where the spacecraft should be, with nothing to do afterward, but wait out the better part of an hour to learn it had gone unanswered again. The odds only got worse the longer it went. Its batteries could freeze solid, its fuel lines could crack, and every week, in that slow tumble, handed a new chance to fail. Day after day, into a silence that gave them nothing, they sent up one simple instruction: if you can hear this, answer. What gets me about that is the sheer stubbornness of it. 7 weeks of talking to a machine that by every rational read was already dead, on the bet that physics and patience might one day line the antenna up for a heartbeat. Kawaguchi wasn't the only one quietly preparing for a fight he hoped wouldn't come. Down in the propulsion group, an engineer named Hitoshi Kuninaka had built something into the ion engines before launch that he hoped he'd never touch. Each ion engine had 2 working parts that both had to run: the ion source that made the beam, and a neutralizer that balanced its charge. Kuninaka had wired in a set of connections, a quiet contingency, that would let the healthy half of one engine be paired with the healthy half of another. It was insurance against a disaster he couldn't yet name, and the obstacle in front of all of them, even if the probe answered, was brutal. It had no propellant left for its attitude thrusters. Its sampler had probably fired nothing. And it was 3 years behind schedule and running on engines already worn past their design life. Which brings us back to that tone on the screen in January of 2006. When the carrier wave finally came through, it was thinner than anyone wanted, a machine reporting for duty from the very edge of failure. Over the following weeks, the team coaxed real telemetry out of it, and the picture that came back was grim and astonishing at once. The spacecraft was alive. It was also almost completely disabled. With no fuel left for the attitude thrusters, they pulled off the first of the improvisations this mission would become known for. They vented raw xenon gas out through the ion engine nozzles, using it as a crude cold gas jet, and slowly wrestled the tumble back under control. Even that was only the start of the damage report. A large part of the spacecraft's batteries had been ruined in the cold and the chaos, and 2 of the 4 ion engines were already dead. The craft that answered in 2006 was, in almost every way you could measure, a wreck that happened to still be transmitting. But that faint signal was everything. The moment it came through, the mood in that room changed completely, and suddenly there was a spacecraft to save. Then they nursed it, for years. They closed the sample canister in early 2007, hoping anything, had drifted inside during that clumsy touchdown and pointed the spacecraft home. The trip back was supposed to take a couple of years. It ran to more than 3. Those last years were a skeleton operation babysitting a dying spacecraft, coaxing a few more hours at a time out of engines that were supposed to have given up long before. And what stays with me about this stretch is how unheroic it all was. No single dramatic rescue, just months of patient, unglamorous refusal to let go. They left the asteroid in the spring of 2007 with 2 Ion engines limping along, and by early 2009, they were down to 1. Through that year, even the Survivor faded, its neutralizer slowly wearing out, its push sagging, until in November of 2009, it tripped offline and stayed there. And that was the true crisis, worse in every way than the silence. To make its narrow window home in June of 2010, Hayabusa needed a working Ion engine, and it no longer had a single one. So they built one out of the corpses of 2. This is the part I couldn't quite believe when I first read it. Kuninaka's team reached back to that contingency wiring and did the exact thing it was made for. One dead engine still had a good neutralizer. Another dead engine still had a working Ion source. Each was useless on its own. But wired together, the good neutralizer of the one feeding the good Ion source of the other, they made a single functioning thruster out of 2 separate failures. It was a configuration that couldn't be properly tested on the ground, only trusted. The whole plan now hung on stitching the good parts of 2 failed engines into one working whole, out at the far end of a radio link where a mistake couldn't be undone and wouldn't even show up on a screen for 16 minutes. As Kuninaka put it, although we built this only for emergencies and never thought we would actually have to use it, that jury-rigged engine ran for thousands of hours and it carried the spacecraft the rest of the way home. And I find that astonishing, that a machine everyone had buried in December of 2005 came back across the solar system on an engine that didn't really exist until they built it, in deep space, out of 2 failures. On the 13th of June, 2010, Hayabusa reached Earth, and it came home in the only way it still could. The spacecraft itself was never designed to survive re-entry, so as it released the small sample capsule toward the Australian desert, the team turned it deliberately, one last time, to take a final photograph of the Earth, and then let it follow the capsule down. It broke apart high in the atmosphere in a long streak of fire. A NASA aircraft full of scientists was in the air over the outback to watch it happen, and the footage shows the mothership shattering into a spray of glowing fragments, the brightest artificial meteor most of them had ever seen, while one small point of light, the capsule, sailed on ahead of the fire, untouched. It came down under parachute over the Woomera Range in South Australia, and search teams combed the outback to find it, a scorched sphere barely a couple of feet across, sitting in the red dirt with its heat shield blackened and everything sealed inside it intact. And then came the second reversal, the one that answered all the doubt about that failed sampler. Inside the canister, when scientists finally opened it, were about 1,500 tiny grains of the asteroid Itokawa, most of them microscopic, finer than dust. They'd brought home the first physical piece of an asteroid ever returned to Earth, from a canister that had very nearly come home empty, and a returned sample is worth far more than it might sound. Meteorites fall to Earth all the time, but they arrive scorched from the plunge through the atmosphere, contaminated by the ground they land on, and stripped of any address, because you can't say which asteroid a given rock broke off of. A sample sealed in a capsule and carried home is pristine, and you know exactly which body it came from. So when teams published their analysis in the journal Science in 2011, that pinch of dust settled an argument that had run for decades. The most common asteroids out there are a type called S-type, and the most common meteorites that fall to Earth are a kind called ordinary chondrites, and researchers had long suspected the two were the same family without being able to prove it. The Itokawa grains proved it, showing a surface weathered by radiation just enough to have disguised the match. It still stuns me that a haul that small, dust you could lose in a sneeze, carried an answer that big. And that's the deeper reason this bruised little mission matters so much. The 2 asteroid sample missions that came after it, and succeeded so cleanly, Japan's own Hayabusa 2 and the American OSIRIS-REx, are in a real sense this one's children, and both of them worked because their designers had a detailed map of everything that could go wrong, drawn by a spacecraft that had gone wrong in all of those ways first. Now I want to be honest about what keeps me from calling this a clean triumph, because three things sit uneasily against the happy ending. The first is that the sampler almost certainly never fired the way it was designed to. Those 1,500 grains got in as loose dust, stirred up when the horn brushed the surface, which means the single most important goal of the whole mission succeeded partly on luck, and came within a whisker of returning an empty box. The second is that the machine didn't survive its own homecoming. It couldn't. It was built to burn, and it burned, and there's something in that I've never quite made peace with. A thing that worked so hard to get back was gone the moment it arrived. And the third is the one that actually stings. A mission held together with this much improvisation isn't really a model anyone wants to copy. The ones that followed flew clean precisely because they fixed everything Hayabusa got wrong, which means this triumph doubles, honestly, as a catalog of what not to do. So can a machine end up being more than the sum of its failures? Cautiously, I think the answer here is yes, though not quite for the reason it first looks like. When I go back over the whole 7 years, the thing that actually brought Hayabusa home wasn't some hidden reserve of engineering strength, because there wasn't one. It was that the people in that control room kept refusing to stop calling, and kept improvising around each new death, long past the point where quitting would have been completely defensible. And even then, what they really did was keep it alive long enough for the physics to finish the job. Sunlight was what turned the antenna back toward Earth. The pushing came from one working half of each ruined engine, and the engineers, for their part, just refused to let go long enough for any of it to happen. So picture the desert in South Australia, late at night, in June of 2010. There's a small scorched capsule sitting under a parachute in the dark, holding a pinch of dust from a rock 180 million miles away. And in the sky above it, for just a few seconds, a long bright streak, the spacecraft that carried it, breaking into light. That whisper the team caught back in January of 2006, the bare tone that only said something is still alive out here, finally got its full answer 4 years later, written across the sky over a desert. The history of spaceflight is full of machines that everyone had already given up on, right up until they didn't stay that way, and I find those the most human stories in the whole field. If you want more of them, subscribe, and I'll keep finding them and bringing them your way.